Session 2013-1. In order to charge the capacitor, you connect up the series circuit that's presented in this figure, where we have a resistor, we have a battery, we have a capacitor, and a switch. The capacitor is initially neutral, and we have C is equal to microfarad, so it's initially neutral. We close the switch, and you have A, it carries a charge Q. So part 1, write the expression of Q in terms of UAB. So we have Q is equal to C times UAB. Part 2, derive the differential equation that governs the variation of Q. So in terms of Q, we'll start with the law of addition of voltages, where we have U of the generator is equals to U of the capacitor plus U of the resistor, which means E equal U of the capacitor, it's Q over C. U of the resistor is Ri, where we have I equal plus dQ over dt. So E equal Q over C plus R dQ over dt. We can divide by R, so we'll get dQ by dt plus Q over RC is equals to E over R. So this is the first order differential equation. Now, using the differential equation, deduce that the expression of the current at T0 equal to 0 is I0 equal to ER. So once I'm using what differential equation, this is what we'll use. So we get as differential equation dQ by dt plus Q over RC is equal to E over R. Now, by using this differential equation, I want to say at t equals to 0, what's the value of I? So if you use this part at t equals to 0, then we'll get that dQ by dt at t equals to 0. We know that at t equals to 0, the capacitor was uncharged. This means Q was equal to 0. So dQ over dt will become equal to E over R, since this is 0. Then dQ over dt, this is what we mean by the current, which is at t equals to 0. So I equal to E over R. The expression part B, we want to find the expression of the maximum value Qm of Q in terms of C and E. Now, in order to find the expression of the maximum value, so we'll say that we have QA will tend to a constant value, which is Q maximum. Okay, how to find this Q maximum? So in order to find Q maximum, at the end, there's no current. If there's no current here, the question is the maximum. When I'm talking at the maximum charge, this means at the end of the charging. So at the end of charging, we have maximum Qm, where we have a current, so the current is equals to 0. If the current is equals to 0, which means that dQ by dt is equals to 0, which means that we will still have Q over RC is equals to E over R. So by simplifying, this means we'll get Q, this is Q, which is equals to Q maximum, will be equal to C times E. Now, we continue. Using the graph, so we have now a graph, the variation of Q as function of time is represented in this figure. And we have a straight line OM represent the tangent to the curve. Part 1A, indicate the maximum value Qm of Q. So if we look at the figure, the maximum value Qm is equal to 10 to the power minus 5 Coulomb. Part B, deduce the value of E. So we already said that Qm is equal to C times E, where this means that 10 to the power minus 5 is equal to C was 1 microfarad, so 10 to the power 6 times E, then we'll get that E is equals to 10 to the power 4. E will be equals to 10 volts. Okay, continue. Part 2A, show that the value of I0 is 1 milliampere. So in order to find the value of I0, so we have here, in this figure, we have the tangent. When I say I want to find the value of I0 is equals to how much, this means I will take at t equals to 0 the variation. We know that I is equal to dQ over dt, but I want it at t equals to 0. So which means it's equals to what? It's equals to the slope. So this is what you call dQ over dt. So this means it's equals to the slope of the tangent at t equals to 0. And this is the tangent here. So by finding the slope, it's equal to y final, which is equal to 10 to the power minus 5 minus y initial 0 over x final, 10 to the power minus 2 minus x initial, which is equal to 0. So we'll get that I equal 10 to the power minus 3. This is I0 at t equals to 0, 10 to the power minus 3 ampere. This means that I0 equals to 1 milliampere. So it's verified. Deduce the value of I. So we already said in the previous part that I0 is equal to E over R, which means that R equal to E over I0. That means E equal to 10. I0 is 1 times 10 to the power minus 3. So we'll get as answer 10 to the power 4 ohm. So this is the resistance. Determine the values of UAB and of I at the instant T1 equal 10 to the power minus 2. So in order to find UAB, which is U of the capacitor, UAB at T1 equals to 10 to the power minus 2 second. So we have a graphically QA. So we'll start with the Q. We have a graphically QA at this instant. So at this instant here, Q is equal to 0.63 times 10 to the power minus 5 coulomb. And then we will find U. So we said that U of the capacitor is equal to Q over C. We have a Q, we have C, which is equal to 1 microfarad. So we'll get as answer, so هيطلع معنا الأنسwer is 6.3 volt. Now we still have to find the current. So as we know, we can find the current by using the law of addition of voltages. So we have E is equal to U of the capacitor plus UR. E is equal to 10 at any instant. UC at T1 equal 10 to the power minus 2 second is equal to 6.3. So this is 6.3 plus R times I. So we have R, which is equal to 10 to the power 4 ohm. Then we'll get I equals to 3.7 times 10 to the power minus 4 ampere. Then this will be the current. Energy stored in the capacitor. Knowing that the energy stored is of the form half Q square over C, determine the value of W at T0 equal to 0. So at T equal to 0, at T0 equals to 0, we have W is equal to half Q square over C, but this is equal to 0, so it's 0. Now at T1 equal 10 to the power minus 2 coulomb, WC equal half Q square over C. We already said that Q is equal to 0.63, so half times 0.63 times 10 to the power minus 5, this is all square, over 1 microfarad, so 10 to the power minus 6. Then we'll get as answer W equal 0.198 times 10 to the power minus 4 joules. Part 2, calculate the average electric power received by the capacitor between T0 and T1. So in order to find the power, the average power is equal to delta W over delta T, which means it's equals to WC, this is 1, so this is 1, W1 minus W0 over delta T, which is equals to T1 minus T0. And then we'll get as answer here, it's 0.198 times 10 to the power minus 4 over T1, which is 10 to the power minus 2. So حيطلع عنا لكن بالآخر الأنسر 0.198 times 10 to the power minus 2 and what?